Welcome back. Today we're going to talk about lesson 1.2, displaying quantitative data. And when we're talking about displaying quantitative data, really the skill we want to pull out of this is how do we describe distributions after we've displayed them. So we can do a box plot, we can do all those kinds of things, but we really want to look at what does it mean to describe those data displays with quantitative data. Quantitative data has the word quantity in it, meaning it's data that's described by a number. So the number of pairs of shoes, number of states that you visited, your height, your weight, things like that. And when we do this, and we talk about describing distributions, we need to remember a couple of different things. One is we need to remember to use context. And two, we need to use descriptor words, LY words. Extremely, very, somewhat, descriptive words. And I say LY words because we need them to describe that distribution. And so a lot of them end in LY. So what's the framework? What is the general outline of what we're going to be looking for when we describe these distributions? So the first thing we want you to talk about is the shape of the distribution. Is it skewed left or right? Is it symmetric? Okay, we want to know what does the shape look like. And our next thing is outliers. And for right now, we're going to be talking about outliers in general. We will have a formula for it coming up in subsequent sections. But for right now, what we can say about outliers is there are potential outliers. And you can say potential outliers on the upper end or on the lower end, those sorts of things. We also want to talk about the center. And there are a couple of ways to talk about the center. The center could be the mean or the median. And when we talk about the mean or the median, it's going to depend on what our type of data is, and really more on what the shape of the data is. We'll talk about that in another section, but when do we use the mean? When do we use the median? And the last part is variability. And variability has to do with how far spread out the data is. How far is the data spread out? What we're going to have for that measurement right now is to talk about the range. What is the range? So what is that upper minus the lower? Let's look at a data display here. We're going to answer some questions about the distribution. We're going to look at this first part of the check your understanding. And the second part of the check your understanding, we're actually going to write up a description using this, what I'm going to call the SOCV, and it comes from shape, outlier, center, variability. And that general outline of what we want to include in a description of a data display is going to be something that we need to remember. So SOCV, shape, outlier, center, and variability. One other thing that they may ask us when we're describing distributions is eventually we're going to have data distributions that are set side by side. So at the bottom here, we actually have two different charts for heart rate. One is resting and one is after exercise. And they're going to ask us to compare those data displays. When we're asked to do that, we need to make sure to add comparative language. Okay, so we need to make sure to add comparative language, so more or less, greater than, less than, bigger, smaller, those sorts of things. Here's a good way to approach a check your understanding in a video like this. I'm going to do the problems and obviously walk you through and explain them. I would like for you to pause right now, try the problem on your own, and then when you unpause, I'll have the explanation here waiting for you. So this is after the pause, so you should have paused and worked on this. So what percent of students scored higher than 16 points? Well, if I'm looking for that percent, I need to know the total. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's out of 21. And higher than 16 points, 1, 2, 3, 4 scored lower than 16 points. So that would be 17 out of 21, or about 81% scored higher than 16 points. what's the shape of our distribution? We notice we have a tail here, and it kind of comes to a crescendo. Well, I like to remember that skew follows the tail. So here's my tail, and my tail is to the left, so this is going to be skewed left. Our last question asks, are there potential outliers? Notice they're not asking about outliers, they're asking about potential outliers. So really all I need to do is I just look over at my data display and I see, are there any values that are far away from the other one? So this one looks like it may be a potential outlier. So a potential outlier at 11, it is much lower than other values. I didn't really commit to anything there. I didn't say it was an outlier, I said it's a potential outlier. So it could or it couldn't be, but there's a potential outlier there, and I just looked at where its proximity was to the rest of the data. So that was number one. Number two, it says that here are two back-to-back stem plots of 19 middle school students' resting pulse rates and their pulse rates after 5 minutes of running. Write a few sentences comparing the distributions of resting and after resting pulse rates. Anytime I'm going to compare distributions, I want to keep in mind that I'm going to use that SOCV mentality, but I'm also comparing, so I'm using the SOCV framework, but I'm also going to be comparing, so that means I need to use comparative language. Good idea to pause here, and now that you have the setup, right, we're going to use SOCV and use comparative language. Go ahead and pause here, try it, and then come back and I'll give you what I had for my write-up for this. Okay, so we're after the pause. As far as shape is concerned, what we notice about the shape is there are data that definitely trails. And if 6.8 represents 68, and this is all the way up to 146, what I'm noticing is that this is small and big. And so that would mean if I laid my number line out like this, I've got a lot of data values that are smaller and then a trail off into the big. And so what I need to make sure that I write up here is not only my context, but what does my shape look like, even though it's turned on its side. So I'm going to say is the distribution of resting pulse rates and after exercise pulse rates are both skewed right. And you'll notice when I say both, that's me using comparative language, right? They are both like this. You could also say they're similarly skewed right. So that takes care of my S. Let me erase my markups here. Next piece, outliers. So let's take a look here. Are there any potential outliers here? Well, I kind of see, the bulk of my data is here. I have this potential outlier in my resting side. And if I notice that my key here, which remember, we need to have a key whenever we do a stem and leaf plot, this would be equal to 120. And I've got a potential outlier here, so this would be at 146. I need to talk about both of those things because I'm talking about two different data sets. So in my outliers, what I'm going to say is for resting pulse rate, there appears there's a potential outlier at 120, and at 146, there is a potential outlier for after exercise pulse rate. So notice a couple of things here. Resting pulse rate after exercise pulse rate. That's my context. Got to have that context in there because when I'm working on writing up a description for full credit and a thorough description, I have to have that context mentioned in there. Center. When I'm comparing the center. Now, center is the mean or the median, and when I'm considering center, I am considering where's the bulk of the data. So for my resting heart rate, it appears to be about right here, and for my after exercise, it appears to be right here. Well, what can I say if I'm comparing these two distributions? What I want to say is that one is higher than the other. So the center comparative language, right? Higher for after exercise than resting. So I've included my context in there. I've also used a comparative language, but also, that makes sense, right? So not that I'm using this anecdotal evidence to, justify my answer, but it makes sense that the after heart rate would be a little bit higher. Okay, variability. So what I need a variability that is going to talk about what is the range of these two data sets. So my range over here for my resting heart rate is going to be high minus low. So I'm going to have 120, which is my highest, minus 68, which gives me 52. And over here it's 146 minus 86, which is equal to 60. So which one has a higher range? So my after exercise has a higher range, and that's what I'll say for my comparative language. So the variability is higher for after than for resting. And notice I put my data values in parentheses here because those were values that I calculated. So when I calculate a value, it's perfectly appropriate to put those data values in there. And what we'll see later is when we do outliers, we're going to say, hey, there's a potential outlier here, or we can say there is an outlier, but you're going to need to show those calculations to be able to do that. So that's the basic gist of displaying quantitative data and talking about it. And that's all I got for this time. So we will see you next time.